Hi gang, I'm going to jump to 4.6, which is actually, sorry, 4.5, which is actually limits. So what we're going to look at in 4.5 is as x goes to positive or negative infinity. So as your input goes to positive or negative infinity. If as you go to positive or negative infinity, your function levels out to a particular height, we say that you have a horizontal asymptote there. Okay, so if we look at this graph here, 3x squared over x squared plus 1, which is pictured over here, we can see as that x goes to negative infinity, which is this, as x goes to negative infinity, the graph is going to level off at 3. And as x goes to positive infinity, you can also see on this side the graph levels out to the same value of 3. You can also see that by analyzing a chart. As x goes to negative or positive infinity, both sides are going to 3. Okay? I have to watch how I say that because as you go to negative infinity, it goes to 3. As it goes to positive infinity, it goes to 3. So it's two separate limits. Okay? The horizontal asymptotes don't have to approach the same value. And there doesn't even have to be a horizontal asymptote. There only is if it levels out as you go to one of the infinities. Alright, now you may remember this from pre-calc. So, from pre-calc, I was teaching, you should have learned how to find a horizontal asymptote. So basically, let me see what order I wrote these in. If the degree of the numerator is less than the degree of the denominator. Okay, so if the degree of the numerator is less than the degree of the denominator, so an example would be like this. This is a case, let me just add a little bit more to it. Okay, so here would be a case where I have a third degree over a fifth degree. And so this is a case where the numerator, the degree of the numerator is less than the degree of the denominator, right? Because the degree of the numerator here is a 3, and the degree of the denominator here is a 5. So when you have that case, the horizontal asymptote is 0. Okay, so when you have that case, the limit of this will always be 0. Anytime I tend to call this bottom heavy, just so this is like a lot of words to say, so you'll notice sometimes I'll just say bottom heavy. It's those two words are way easier to say than this whole paragraph. So bottom heavy means the denominator has a higher x, the degree of the polynomial is higher, which will collapse the fraction to 0 as you go to positive or negative infinity. Okay, now, if they're equal in degree, then it's the ratio of the leading coefficients. So that depends on the particular problem. So let me just give you a for instance. All right, now these are equal in degree. I have them both as quadratic. The top one is a second degree. The bottom one is a second degree. So when they're equal in degree, the limit will be the ratio of the leading coefficients. The ratio of the leading coefficients. So this is 5/3 in the problem I just made up. So you want to just be careful when you do the homework, because sometimes they have the leading coefficient like it's out of order, it's not in descending order. The leading coefficient might sometimes be in the back or in the middle. Just be careful that you find the actual highest degree, because you need the coefficient of the highest degree. Okay, now when the numerator is greater, there is no horizontal asymptote. When the numerator is greater, it's just going to shoot off to infinity. It would be like the flip scenario of this. Right, so here in this one I just made up real quick, the degree of the numerator is 5, the degree of the denominator is, can't read my own writing, 3. So when you, and again I'm going to say that this is chop heavy, because to say this whole paragraph, if the degree of the numerator is greater than the degree of the denominator. Like, that's like a lot too many words to say. I'm just going to say top heavy for this case. If it's top heavy, then it's going to go to one of the infinities. So the limit is dne, and the reason in this case is as I go to infinity, this function's actually going to infinity. And if it's going to infinity, remember that's a concept and not an exact point in space. So the limit doesn't exist. You can't sort of like fit it within a bullseye. By the way, in the future, I want you to write infinity and not dne for these, because as you get more sophisticated, this actually infinity is a better answer because it's more specific than just saying dne. You're saying, when you say infinity, you are saying the limit doesn't exist, and you're actually saying why it doesn't exist because you're going to infinity. All right, so maybe stop the video and see if you can do these three. That'd be sort of cool, and then come back and we'll compare answers. Okay, so I'm going to look at the degree of the numerator. The degree of the numerator is linear. That's first degree. Degree of the denominator is quadratic. Okay, so this would be the case where it's bottom heavy. Anytime it's bottom heavy, that's this case. It's going to go to 0. All right, let's look at the degree of this. Degree of the numerator is 2. Degree of the denominator is 2. All right, so that's when they're equal in degree. When they're equal in degree, you do the ratio of the leading coefficients. So that's going to be 3/5. All right, let's look at this one. The degree of the numerator is 3. The degree of the denominator is 2. That's top heavy. This is going to go to infinity. Everything's going to end up being positive. So for right now, you can write dne, but the actual best answer for this is infinity. Your book will probably write, yeah, in chapter 4, they've already assumed you know the distinction. Okay, so we're going to write infinity for that, but I think as we go along, you'll get a little more clear as when we write that. Okay, I'm going to end this video here and pick up in another one, but I just really want to stress, on your exam, all the limits are going to be all jumbled together, so it's really important that how you recognize this type that I'm doing right now, how you recognize it is that the input has to be going to one of the infinities. The input has to be going to one of the infinities on a fraction. Okay, that's how you know it's these rules. You're going, x is going to positive or negative infinity on a fraction. Okay. All right, gang, I'm going to pick up in another video in a moment. Catch you. Bye-bye.